What? The one you chose to use your makeup on?
Yeah.
We're going to take a look at the law of cosines today, and the diagram that I tried to draw last time I have up here in the upper right hand corner. You're going to be looking at, again, solving triangles, meaning come up with all the missing parts and pieces. So according to what the initial information is that they're giving you will determine how you start the problem. If the information that they're giving you is the fact that you have two angles and an included side, or two angles and a not included side, you'll start that problem using law of sines, which could lead into the ambiguous case, right, which could lead into two possible triangles, no possible triangles, or one possible triangle. What we'll look at today is if the starting information that you're given is all three sides, you don't know any angles, or you know two sides and an included angle. There you're going to have to start with what's known as the law of cosines. Okay? Now last time when we looked at law of sines, it kind of showed you where it came from. We're going to do the same thing for what the law of cosines is. First thing I'll explain with my diagram that you're seeing here is a similar argument can be made. The triangle that you're seeing is a obtuse triangle. A similar argument can be made with any acute triangle. So what we would do with the acute triangle is simply place, again, one of the vertices of that triangle at the origin, just like they did with our current triangle. So point B would be here. Point B will have the point 0, 0. Out here is some point C, and we've traveled some distance A, so point C would have the coordinates A, 0. What I'm about to show you is where does the coordinates for A come from. They have it labeled as C cosine B, comma, and this is X, comma, Y, C sine B, being the coordinates for that point. So again, where are those coming from? On the obtuse triangle, if you were to focus on this right triangle, you can see that angle B, the sine of angle B, equals opposite Y over hypotenuse C, and the cosine of B would be X over C. And then when you cross multiply, right, or solve these for X and Y, here you would get Y is equal to C sine B, and you get X is equal to C cosine B. You can see where that's coming from, right? And the same argument would hold over here. If you drop a perpendicular segment down, call this X, that distance X, call this distance Y, this point would have X, comma, Y, and now using B again, you'll get the same coordinates. You'll get the same X is equal to C cosine B, and you'll get the same thing as Y is equal to C sine B. All right? So what I'm about to show you with this obtuse triangle, the same argument holds for an acute triangle. Once we understand where the labeling's coming from, whoa, let's go back up there, get rid of this stuff. Okay, once we understand how this triangle is labeled, this point has coordinates, B has coordinates 0, 0, C has coordinates A, 0, and now point A has coordinates C cosine B, C sine B. Where the law of cosines comes from is we simply apply the distance formula. Let's come up with the distance of B using distance formula. What's the distance between point A and point C? So the distance formula is D equals square root of all that. So let's get rid of that big square root by squaring both sides. That's the same thing as saying B squared. B would be the distance, so square that. On the right-hand side, we would have the difference of the X coordinates, which is C cosine B, minus A, that quantity squared, plus difference in the Y coordinates, C sine B, minus 0, that quantity squared, right? And I'm not writing the big square root because I squared both sides of the distance formula. So let's simplify the right-hand side. We would get a b squared. Now I'm going to square that first quantity. Squaring a binomial means we square the first term. That would give us a c squared cosine squared b. Now I multiply the two terms together and I double it. That will give me a negative 2ac cosine b. Square the last term gives us a positive a squared. My second quantity is nice because c sine b minus 0 is c sine b, and all I got to do is square that to get a positive c squared sine squared b. Any questions so far? All I'm going to do is simplify the right-hand side, which will quickly lead to what the law of cosine says. What else could I possibly do on the right-hand side? Well, you and I are going to group or reorganize the terms so that these are next to each other. Manipulate your terms. And we can factor out a c squared. So that gives us c squared times the quantity cosine squared b plus sine squared b minus 2ac cosine b plus a squared. And what do I have in parentheses? Sine squared b plus cosine squared b is just 1. So 1 times c squared gives us c squared. And we have the end. We have a b squared equals a squared plus c squared minus 2ac cosine b. There is one version of the law of cosines. One version. So it's like, think of it this way. You got three sides in the triangle, right? You got side A, you got side B, and you got side C. So the one that you're interested in finding, side B, okay? Take a look at the other two sides are located on the right-hand side. So if you're interested in figuring out side B, you're going to need to know side A and side C, because they go here as well. And you're also going to need to know the angle across from the side that you're looking for, which is stated in all three versions. Okay? See the relationship? If I'm looking for A, I'd better know B and C, because they go here, 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 and I need to know the angle across from the missing side. All right? So let's use this to solve a couple problems. This question says that a surveyor wishes to find the distance between two inaccessible points A and B on opposite sides of a lake. While standing at point C, she finds that AC, the distance AC, 259 miles, BC is 423 miles, and the angle in between those two sides is 132 degrees 40 minutes, which let's go ahead and change that to 132 degrees, 132.67 degrees. 40 out of 60 minutes is 2/3, so 0.67. Find the distance AB. So do you see what I mean by here is a side, in terms of information that you know, here is a side angle side situation, telling you need to start with the law of cosines. So AB squared, the side that we're looking for, which we'll call AB squared, using law of cosines, is equal to what? Well, the other side squared, 259 squared, plus the other side squared, 423 squared, minus 2 times each known side. So 2 times 259 times 423, and then yet that multiplied by the cosine of our angle, 132.67 degrees. And I want to remind you, folks, that's what B squared, or AB squared is. We'll have to turn around and take the square root of that to get the actual length of that side. So go ahead and make sure your calculator's in degree mode. We'll say, calculator, we need you to take 259 squared plus 423 squared minus 2 times 259 times 423 times the cosine of 132.67. So there's my b squared value, 81,728 point some decimal. So I'm going to turn around and right away take the square root of previous answer. Square root of previous answer, 285.88. So AB, 285.88 meters. So this was not a solve the triangle problem. This was just a call out a certain side or an angle that you're supposed to find. The next two problems that we're going to take a look at are the examples where your job is to come up with all the missing pieces of the triangle. So let's draw a triangle for our first example and label what we know. We'll draw a generic triangle. Even though my generic triangles all look acute, we know that it is possible that it could end up being an obtuse triangle. A, B, C. We know that angle A is 42.3 degrees. Side B, 12.9. And side C, 15.4. And again, as I stare at that triangle, you can see that in terms of information that I'm starting with is a side angle side situation. I can't use the law of sines with this problem because I only know one angle. And the sides that I have there, I don't know the angles across from them. So, I'm kind of stuck with I can't use law of sines. So let's start by finding side A using law of cosines. Side A squared equals what? Well, it equals the other two sides squared. Add them together. So 15.4 squared plus 12.9 squared minus 2 times 15.4 times 12.9 times cosine of 42.3.
It's always like that?
That's always, yeah, that's the law of cosines. So we get an a squared value. Well, I'm not going to write a squared. Our calculator will have a squared. We'll go in here and take 15.4 squared plus 12.9 squared minus 2 times 15.4 times 12.9 times the cosine 42.3. 447 point some decimal. Turn around and take the square root of the answer. 21.16. A is 21 point. Uh-oh. Did I enter something in wrong? 15.4, 12.9. I should have got 10.47.
That's what I got.
So I
Don't
entered.
you have to put parentheses after minus 2 times 15, parentheses all that bracket?
$15.4 squared plus 12.9 squared minus 2 times 15.4. No, it should know order of operations. Mode. I'm in the wrong mode. Degree mode. I even said make sure you're in degree mode. I never checked my own calculator. Which means my previous problem's probably wrong too. 109 points, so that now take the square root of that. square root of previous answer, and there we get 10.47. All right, so our previous problem, that is not the right answer, is it? Previous problem, let me change that quickly. Let me redo that in, this time, my calculator in the right mode. Maybe I could still call it up from a, maybe the calculator still has it in memory. Nope. Yeah, there it is. That answer should have been 628.11. So there's what happens when you have your calculator in the wrong mode. Glad I recorded that. Okay, 10.47 we got for side A. I have side B, I have side C. Now I got to find my two angles. Here's where I feel that your textbook didn't do a very good job stressing the fact that if I would ask the question, does it matter which angle I find first, B or C? And you might think, no, it doesn't. Yes, it does. Here's why. In geometry, and again, I don't know who had high school geometry or who didn't, but if you did have high school geometry, one of the facts that you learn about a triangle is that the largest angle will always be across from the longest side. The shortest angle, smallest angle of a triangle will always be across from the shortest side. Okay? So when I look at my three sides, I now know that A is 10.47. Okay? Which angle has to be the largest angle? C. Now, that's why we want to try to find B next. Okay? We need to use the law of sines to come up with our angles, right? And when we do law of sines to come up with angle B, I'm going to get two choices. Remember that we have a quadrant 1 possibility, and we also have a quadrant 2 possibility, because we're going to find out that the sine ends up being a positive number, putting us in either quadrant 1 or quadrant 2. Now, if I get, let's just, and I'll show you what's going to happen. Let's say we get these two possible answers for angle B. One possible answer for B is 61 degrees, which, let's make it easier on the math, 60 degrees, which means the other angle ends up being 130. Okay? I know right away I throw this one out because C has to be bigger than this angle. And you can't have two obtuse angles in a triangle. See what I mean? Whereas if you find C first, then you're not sure. You don't know what to do. So we want to find the smaller of the two angles next, which means we want to try to find angle B. So using the law of sines, I'm going to use the space that I have down here at the bottom. Using the law of sines, we can now say we want to look for B, right? So the sine of B over side B, which is 12.9, equals the sine of A, which is 42.3, over the side we just found, 10.47. So sine of B ends up being, we're going to take and cross multiply, divide. So the sine of B ends up being 12.9 times sine of 42.3. And then we're going to turn around and divide that by 10.47. So we get a sine of 0.8292. And that's positive. Sine's positive. So that puts us in quadrants 1 and 2. So now I say, calculator, inverse sine inverse sine previous answer, and we get an angle of 56 degrees. But see, now I don't have to worry about the other angle, because angle C I know is bigger than this angle, and I can't have two obtuse angles. So I know this angle has to be 56.01 degrees. So angle B, 56 point, whatever I said, 02. One more angle to find. Now we'll go ahead and just simply subtract off 180. 180 minus previous angle, 56.02, minus original angle, 42.3, gives us our final angle, 81.68. So there are the remaining sides and angles. Okay? Let me clear some space down here at the bottom. And go ahead and try that one, please. Draw a triangle. Start by using the law of cosines. Come up with what you think the missing pieces are. So let me draw a triangle and label it. Triangle ABC. A, 9.47. B, 15.9. C, 21.1. And it really doesn't matter which angle you try to find first. The one I tried to find first was angle A. So let's just write that we have 9.47 squared. Doesn't really matter which angle you find first. We should all end up with the same three angles. But I wrote the fact that 9.47 squared is equal to 21.1 squared plus 15.9 squared minus 2 times 21.1 times 15.9 times cosine A. And here's where I'll solve this equation, right, for cosine A. Cosine A is equal to, on the bottom, right, we're going to end up dividing both sides by -2 by that product. But up top, we're going to have, 9.47 squared minus 21.1 squared minus 15.9 squared, and then I divide both sides by -2 times 21.1 times 15.9. Right, so I took the law of cosines equation, solved it for cosine A. And now when we do all of that arithmetic on the right-hand side, we'll get the fact that cosine A is 0.9066. And here's something else that's really nice about the law of cosines. Here is a cosine that is positive, right? Positive. What two quadrants do you have a cosine being positive? 1 and 4. You don't got to worry about the quadrant 4 answer. You can't have an angle in a triangle that's between 270 degrees and 360 degrees. So you only have to worry about the quadrant 1 answer that you get. So if I say calculator, inverse cosine 0.9066, we get an angle of 24.96. So angle A, 24.96. .96 angle A. Which angle should I find next? I should find B next, for the same argument that we had in the last problem. Okay? If C is obtuse, B can't be obtuse. So let's find angle B next. So the sine of B over side B. Again, we're using law of sines here. Sine of B over 15.9 equals the sine of our new angle, sine 24.96 over the side across from that angle, which is 9.47. And we get angle B being 45.09. Which makes angle C, when you subtract them both from 180, 109.9. Now, maybe you started this whole problem up here by finding angle C first. If you did you get 109.9? I don't know what angle you found first, but your three angles and my three angles should have ended up being the same angles.
I got 70.05.
You want me to, I can look at, see if we can find your mistake later.
Probably the calculation.
109.94.
Yeah, okay. Any questions? Any questions? Sorry, there's not a law of tangents, which is just the law of sine divided by, no. Now another theorem that is derived from the law of cosines is what we call Heron's formula. And what's nice about this guy's formula is if you have a triangle and you only know what all three sides are, you can find the area of that triangle without knowing anything about the angles. So the first thing you have to compute is this thing called the semi-perimeter, and we all know that semi means half. Semicircle means half of a circle. So we want half of the perimeter. That's why we add all three sides together first, find the perimeter, and cut it in half. That's our S value, semi-perimeter. It goes here, 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 and here. All I do next is fill in the A, B, and the C with the lengths of the three sides of the triangle, do the arithmetic, and guess what? You found the area of that triangle. And again, this formula is derived from the law of cosines. It's in your textbook. It's a 2-page derivation. It actually, they take the law of cosines, do algebra, takes up 2 pages. So I really don't have class time to go over where the Heron's formula is actually coming from. It takes a while. So our problem says that the distance as the crow flies from Los Angeles to New York, 251 miles. From New York to Montreal, 331 miles, and from Montreal to Los Angeles, 2,427 miles. What is the area of this triangle? So we'll first come up with what the semi-perimeter is. S is equal to 1/2 of the perimeter, 2,427, plus 2,451, plus 331. So I add them all up, cut it in half, and our S value ends up being 2,604.5. Anybody have any questions there? Same S value? And now taking that S value and taking the three sides of our triangle, we plug them into the area formula. Area is equal to the square root, big square root, of S times the quantity S minus one of the sides, A, 2,451, times the quantity S, 2604.5, minus the next side, 331, times the quantity S minus our remaining side, which is 2427. It's a square root of that whole product. So into our calculator, enter it all in at one time. Square root of, left parenthesis, 2604.5 0.5, left parenthesis, 2604.5 minus 2451, close, open. 2604.5 minus 331, close, open. 2604.5 minus 2427, close, close. Square root of that whole thing. And we get roughly 401,664
Wow. Square miles?
square miles is the area of that triangle. That's pretty neat. I mean, to be able to find the area of a triangle, any triangle, right, obtuse, acute, any triangle, knowing the three sides.